Hey everyone, my name is Anthony. Cut. Have you ever wanted to know what is actually going on inside of your computer? This video today is going to tell you about the different computer components and how they work together so that you can have a functioning computer system. Now this right here is probably typically what you're used to seeing when you think of a computer. Everything's in one case. You plug your wires or whatever your headphones in to the front. You hook your monitor. You hook your monitor up back here. Maybe your keyboard, mouse. I don't know, maybe a printer, something like that. And you don't ever think twice about it until something goes wrong. And then you really think this is just like a big paperweight. Or you take it to somebody to fix it, or something along those lines. Now, one thing that most people don't realize is it's very easy to get into this computer and see if something might have actually popped out or shorted, or just see if, you know, even the fans are running when you turn it on. Usually there'll be a thumb screw, which is a whole lot easier to take out on one side of the case compared to the other side usually has an actual screw that's hard to get to. Additionally, whatever side your I/O ports are at, or input-output ports, whatever side they're on, typically you'd like to take the other side of the case off. So we're going to take the case off now just to show the inside of this computer. We got just a little shroud right here that goes over this fan, and it helps suck the air out to keep our CPU cool. One of the worst things for a computer is heat, and with electronics, they heat up the more you use them. So of course there's going to be multiple fans in a well-made case to help it circulate air, and if it's really well designed, you won't have as much dust build up because of the way the airflow works. But for simplicity's sake, instead of taking this computer apart, we're actually going to use a demonstration board that I made, which is right here. Now this has everything in it that this computer I just showed you has, except for, as you can see, it's all laid out on a board. And I'm going to go ahead and turn it off, because you can see that fan spinning right now, so that we know it's turned off. Alright, now, on this computer we actually have our CPU cooler, which of course the CPU is going to be behind it. We have our RAM. Our RAM over here is going to be hard to see. Actually, let me lay this board down so we can see it better without all that light. Okay, here we are. Now you can see the board a little bit better. Let's go ahead and start with the power supply. Every computer's got to have a power supply. So what that does is it takes your power from your wall outlet. It converts it to a DC output so that your motherboard, your hard disk, RAM, everything, so that everything has power. The way it does that is it actually has wires. You'll see right here coming up the back side of this power supply. Power supplies are usually rated for a certain wattage. You'll see this one's rated for 300, which is a pretty standard size for pre-built computers. That's in maybe, you know, like the $300 to $500 range. You know, cheaper computers are going to be made with the cheapest amount of components as possible, and you're not going to see the big 500-600 watt power supplies in it until you get into a computer that has graphics cards and all that kind of things. Alright, so from there you can see it goes to our hard drive. The power goes to our hard drive. Hard drives usually come in what is considered to be a mechanical hard drive, which means that there's actually a disk in here that's spinning really fast. It's actually spinning at 7,200 RPMs. some of them spin at 5,000, some of them spin at different speeds. This one spins at 7,200 RPMs, which is, it's just going to give you a little boost in performance. So they also have what is called solid state drives, which doesn't have that mechanical that disc in there spinning. One of the benefits to a actual solid state drive is it's going to be significantly faster. Usually they have lower storage amounts, but they are so much faster that it's really nice to have a SSD or solid state drive. From there, this is something that normally wouldn't be on a computer. It's on this computer so that I can turn it on and off without having to take a screwdriver and turn it on and off. Alright, now let's get to the motherboard, because this is really where it starts getting exciting. The motherboard is going to have all the other components attached to it, like your RAM, your CPU, your graphics card, audio card, anything else that you might want to plug in to use, like a printer or Xbox controller for games, pretty much anything. So let's start with the CPU cooler first. This is just a cooler. It's got aluminum fins down here. Let's see if I can get this to, there we go, focus. Now these fins suck up the heat from the CPU, and without having to take it off, I got a CPU right here. And what this CPU does, CPU is your central processing unit, and it's like the brains of the computer. And it gets really hot. Like it gets up to 80 degrees Celsius, which is like 100 and something Fahrenheit, so you can't touch it or nothing. And it's got to be cooled off, so that's what we got, these CPU coolers. Here's another CPU cooler right here. You can see this mounts to the top of your CPU, like that. And then it pulls the heat from the CPU through these little aluminum fins. Well, the copper conducts the heat very well, so it pulls it up, and then it dissipates through these aluminum fins. Now, there would actually be a fan on the other side of this right here that's pulling or pushing air across these fins to help cool it. But a lot of times the whole cooler is like you see right there, or like this example. It's one unit. You got the heat sink that sits on top of the CPU, as so. And then the heat sink pulls the heat from the CPU, and this CPU cooler dissipates the heat. So there you go. That's your CPU, and that is your cooler. Now, the CPU is important because, of course, it's going to handle all aspects of the computer when it comes to video editing, playing video games, web browsing. The CPU is always being used to pretty much tell the computer what to do, how to do it, what you want it to do, and when you want it to do it. Alright, from there, we're going to go to our RAM. Now, our RAM is actually hid behind this cable right here. We'll take this off for right now. This is our power cable for the main. This is our main 24-pin power cable for the motherboard. Alright, now, RAM has little tabs that you push out, and the RAM pops right up, like that. RAM is important because it's actually, RAM stands for random access memory. And what it does is it holds, RAM's very important because it holds whatever program you're working on in the memory and allows you to work with that program in real time. Meaning, RAM is what you're using when you're, let's say you're playing a video game. Let's say you're playing Fortnite and you're up there and you got, all these trees on your screen. You got all these buildings and stuff. All that stuff, the only reason it's able to be displayed is because it's being held in your RAM or in your random access memory. The reason we use RAM to hold that kind of stuff instead of a hard drive is because the RAM is significantly faster. Therefore, you can make changes and do things like look around or cut a tree down or destroy a building, and the RAM can handle whatever the video card is requiring to display. The RAM can make that changes very fast. Whereas, like a hard drive, when you go to load into your game, it takes longer to load because it's loading a lot of information from the hard drive and putting it into the RAM. so that the RAM can therefore utilize it in a productive manner instead of it just sitting on a hard drive. Now, so it would seem like we would just use RAM for everything if it's faster, but RAM also loses its memory whenever you turn your power off. Alright, so what I mean by that is, let's say you got Windows 10 on your computer. When you turn your computer off and turn it back on, you expect Windows 10 still to be there. The reason that can happen is because the hard drive disk, even when it loses power, whatever it is stored in its memory continues to stay there. Now, RAM, whenever you turn your power off to a computer, it deletes whatever was in that memory, and when you turn the computer back on, it's like a brand new start. So that's why, a lot of times for troubleshooting, people will say restart your computer, because it eliminates anything that might be residing in the RAM that is causing the computer to malfunction. Alright, so when you insert your RAM, see if I can get me a good little close-up of it. When you insert your RAM, there's usually going to be a little tab in the center. Of course, different generations of computer uses different types of RAM, so that keeps you from putting the wrong size RAM in a computer. Now, when you put it in, you want to make sure that these tabs on the outside are pushed all the way out, and you want them to close by pushing down on your RAM. And you hear it click on each side, and you know you got a good connection. You can have a lot of problems by accidentally, if I push this in, I heard that one side click, and I didn't push this side in all the way, it didn't click. I could turn my computer on, it go to beeping and doing all kinds of crazy stuff because of something so simple as I didn't push it all the way in. So you put a little bit more pressure on it and you'll hear it click. There we go. Alright, so that's our RAM. Let's go ahead and plug our 24-pin connector back in. Alright, so that's looking like most of the important parts of the computer on the inside. The only thing we missed is our graphics card. Most computers have what is called integrated graphics. So you don't need a dedicated graphics card. Integrated graphics are great for simple web browsing or doing things that are not very graphic intensive. Graphic intensive programs is video editing and playing video games. So what your graphics card does is goes in this slot right here. This is going to take the graphics card and mount it to the motherboard so that the motherboard now has a dedicated graphics card. Therefore, you can have more performance when it comes to video editing or gaming. So let me grab the graphics card and we'll show you that too. Now the graphics card is going to be mounted in this PCIe slot. This is actually a PCIe 16. It's pretty much the same concept as the RAM. It's got a little tab that's got to be pushed back that locks it into place. But with the graphics card, when you mount the graphics card, you want to be able to plug your monitor into it. Like right now, it's plugged into my integrated graphics right there. When I mount my graphics card, let's see if we can go ahead and get a close-up of me mounting it and get it in there. Alright. Now we want to make sure everything lines up and then push it straight down. It'll pop right into place. Now we would hook our monitor up to our graphics card so that we would be able to use our dedicated graphics instead of our integrated graphics, and that would give us superior performance when it comes to gaming or video editing. Now, nowadays graphics cards have become a whole lot larger than what they used to be, and as well a whole lot more powerful. A modern graphics card could be expected to be this size or even larger, and I think it's pretty simple to see the size difference in comparison. Now, of course, with that increased size, that also means that this card would take more power. That means that we'd have to hook up a 4-pin and a 6-pin power supply, which this power supply doesn't have because, like I said, it's only a 300 watt. And this graphics card alone takes probably like 200 watts. So this graphics card wouldn't work in this computer based off this power supply. Now this is where it gets really exciting when you're building computers and starting to upgrade them. You can always upgrade something in the computer, whether it's your RAM, whether it's your power supply, hard drive, graphics card, CPU, CPU cooler can also, if you get a better cooler, it can make your CPU perform better because it stays cooler. There's numerous things that you could do to upgrade. So let's say I did want to use this graphics card on this computer. I would just go buy another power supply that was rated for probably 500 watts instead of 300, where it says the maximum power output. And that way it also probably would go ahead and have my 6-pin and 8-pin connector for this graphics card. I'd plug my graphics card in, hook my monitor up to my port, whatever one. I got an HDMI, I got DVI, I got mini display, I got all different. I could have 1, 2, 3, 4, 5, 6. With this setup, even though there's only 5 connectors, I could actually have 6 monitors hooked up to this one graphics card. That's a serious battle station. Alright, so that's pretty much the breakdown of all the computer components. Of course, there's a little bit more in depth to each component, and how the speed it works at, the different memory sizes, and there's numerous different things that change over time to increase performance in new computer parts. But the general idea of the computer hasn't changed. You got to have a storage device, which is your ROM, which is going to be this hard disk, which is read-only memory. Then you're going to have a power source, which is right here. You're going to have some kind of RAM, which we talked about the RAM, and you got to have a central processing unit that'll do all the computing tasks that makes computers so wonderful. So I hope this little tutorials helps you out in understanding computer parts. If you have any more questions, or maybe I missed something or said something wrong, maybe I said something that was wrong, then just leave a comment in the bottom. If this video helped you out, please like it, share it with your friends, and stay tuned for future computer related videos.